So in this video, I will explain the pressure volume diagram. So we have seen how the properties of a pure substances changes when it is heated and when it is undergoing the phase change process. Now let us plot the changes with respect to pressure and specific volume. Okay, so here specific volume is defined as the total volume divided by mass, or you can write it as 1 by mass by volume. So this is equal to 1 by density. So this is the specific volume. So let us draw the y-axis and the x-axis. In the x-axis we will plot the specific volume, and the y-axis you will draw the pressure. So I told you here when it is heated, we are heating at constant pressure. Okay, we can do this experiment like that. We can later do a different experiment. Now we are heating this solid or the substance at a constant pressure. So that means, so when it is heated, so initially it will be like this. So it will be so let it be initial state be 1. Sorry, let it be 1. So that is a solid. When you heat it, so 1 to 2, right? See, let us see that what is 1 to 2. So let us call this 1 and this as 2, this as 3. So 1 to 2, that means you are getting the saturated solid, and 2 to 3, the solid is getting converted to liquid, that is in a phase change process. So during 1 to 2, what happens to this specific volume? You know that when a substance is heated constant pressure, it try to expand, that is specific volume increases. So you can see that this V2 is greater than V1. Now again it is heated, so that means 2 to 3, so it is getting converted to liquid. Again its specific volume increases. Okay, so then from 3 to 4, okay, it becomes saturated liquid. So you can draw that it is 3 to 4 here. And then the most important part, so from liquid to vapor, it undergoes a phase change process. During this process, this vapor specific volume is way bigger than that of that liquid. So that means you can see a big increase in enormous increase in specific volume. So I am showing a cut here. So let us draw it like this. It shows that enormous increase in specific volume when the pure substance E undergoes phase change process from liquid to vapor. So it has become 5 here. Now it is 5 corresponds to vapor, and then if it is heated further, it will become superheated vapor. So let us note down the important points here. 1 is solid, 2 is saturated solid, 3 is saturated liquid, and then 4 is again saturated liquid, and 5 is saturated vapor, and 6 you have superheated vapor. You have superheated vapor. So these are the 6 important states. Now, so we are doing this for a particular pressure. So this is for, let us do this at 1 atmospheric pressure. Now suppose we are doing this at for some 10 atmospheric pressure. So what happens? What is the difference? So that means, so at we are doing this for at a higher pressure. So you can let us try to predict the change in volume. For example, at state 1, at a higher pressure, will this 1 dash be here, slightly leaning towards right, left, or to the right? To understand this, you need to note that when you increase the pressure, okay, so that means temperature will also increase. Okay, what is the effect of pressure on volume? This pressure will cause the volume to decrease. It will compress it. Okay, what happens to temperature causes the specific volume to increase. It will cause the liquid to expand. So, for solids, if you take solid, this effect of pressure is higher compared to the temperature. Okay, compared to temperature, effect of pressure is high. So that means if you draw this line, you can see that this 2 dash will be here and this 3 dash will be here. That means it causes the specific volume will be slightly reduced at higher pressures. But if you look here, this 4 dash will be to the right. Okay, because in the case of liquid, the effect of temperature, okay, effect of temperature is higher compared to the pressure. So that causes the liquid to expand. So you can see that its specific volume increases, but its effect is very small because liquid is almost incompressible. Even if you increase the pressure, you cannot change the specific volume of the liquid easily. But due to the temperature increase, a specific volume will change. So here also you can see for solid also the effect of pressure and temperature on specific volume is negligible. Okay, so that means, so then it will increase up to here. So this 5 dash is to the left of 5. See, why is it so? That is important. So why is V5 dash is less than specific volume at 5? Because take the case of a gas. A gas can be easily compressed. If you apply pressure, it can be easily compressed. That is, by intuition you can understand that. So the effect of pressure is very high compared to the temperature. So the pressure causes the volume to, specific volume to decrease, to reduce. It reduces the specific volume. The temperature will cause the specific volume to increase, but the effect of pressure is more compared to the temperature. So this 5 dash will be shifted to here. So if you repeat this experiment for various pressures, okay, you will get a vapor. See, you can draw all these state, connect all the locus of all these states. So just I will draw that. So this will be like this, and here it will be like this. Okay, so you can draw this for, see, so this can be done for a, so maybe some 100 atmosphere, like that. Okay, you can do that for various pressures. So you can see here 4 double dash and 5 double dash. Okay, and so you can see that the difference between these two, this 4 and 5, is gradually reducing. That is the difference in the volume. Specific volume is change in specific volume is gradually decreasing. And if you are doing this experiment for a pressure corresponding to 221 bar, okay, so you can almost see there is no change in, you cannot find a change between liquid and gas here, and this point is called critical state, which I will explain in a subsequent lecture. So you will get a dome like this, and this point is called critical point. We will discuss why we are getting a point like that, right? So this is about the PV diagram. One more thing, uh, so now let us draw it to this side. Okay, so if you draw downward, so you will get like this. Okay, so that means I am reducing the pressure. See, this is for 1 atmosphere, so I can do it for maybe 0.5 atmosphere. So again you will get a curve, and if you go below this point, this particular pressure, see, okay, you can see that here. Okay, let us mark the important phases here. So here you have the solid, and then you have the solid plus liquid here, and then here you have liquid, and inside the dome you have liquid plus vapor, and here you have the vapor. So this is how you draw the separate the different phases, because we have already seen that from 1 to 2 it is solid, 2 to 3 it is solid plus there is a phase change process, 2 to 3 is the phase change process, and 3 to 4 is the, so you can see here it from saturated liquid to saturated liquid, so this is the sensible heating process. From 4 to 5 it is from saturated liquid to saturated vapor, there is a phase change process. Then from 5 to 6 again that is a sensible heating process. So we have connected all these locus points, and then we can separate the different phases. So this side you have the solid, and here is solid plus liquid, here liquid, and then liquid plus vapor, and then vapor. Okay, then let us come down to here. So here it is solid, and here you have solid plus vapor. Okay, this region you have solid plus vapor. So that means, so if you are heating at a pressure below this point, so this means I am heating less, so I am starting from here, here it is, let us call it 1 dash. Okay, so if I am heating, this solid will be directly converted to vapor, so there is no liquid phase in between. So this happens when you heat it below a particular pressure, and this line is called triple point line. This is called triple point line. This is not a state, this is a triple point line. That means for a triple point corresponding to this you have a pressure. So this is 0.00611 bar. So below this pressure, if you are heating it, the solid will be directly converted to vapor. This is called sublimation process. So we will discuss about triple point in another lecture. So this is the general PV diagram. So this is how you will show the different phases in a PV diagram.